Hello everyone, it has been some time since my last podcast, but we are getting back into the swing of things after I had an unfortunate event about a year ago which forced me to stop broadcasting. Today we're going to talk about two very important statistical tests. One is correlation and regression, and the other is ANOVA or ANOVA. Correlation is very simply the relationship between two variables, and regression is a measure of that correlation. Correlation is statistically measured with a value from -1 to 1. So a correlation of -1 or a correlation of 1 is a perfect correlation and are rarely encountered. Two variables, again, when we're talking about correlation, we're talking about the relationship of variables. So two variables can have only three possible relationships. They are correlated or positive correlated, meaning that a change in one is followed by a change of the other in the same direction, but not necessarily the same magnitude. They are negatively correlated, which means that a change in one is also followed by change in the other, but in the opposite direction, but again not necessarily the same magnitude. And no correlation, which means that the two variables do not appear to have any relationship at all. A change in one makes no difference in what the other variable does. Now, a negative correlation, a perfect negative correlation, will be denoted with a -1. A perfect positive correlation will be denoted with 1, and the absolute lack of relationship will be denoted with a 0. While a correlation of 0 is not uncommon, as I already mentioned, a correlation of -1 or 1 are not really possible. Perfect correlations simply do not exist. One of the big concepts in statistical analysis is that even a high correlation does not imply causation. What is causation? Causation is the assumption that the change of the first variable is actually causing and not just coinciding with a change in the second variable. Causal relationships do exist, but they require much more in-depth analysis in order to evaluate them and ensure that they're actually causal. The magnitude of the relationship between the two variables is actually measured by the distance from 0 or 1 or -1. So a correlation of 0.02 will be a very weak correlation. A correlation of 0.9 will be considered a strong correlation, whereas a correlation of 0.5 will be considered chance. It's neither weak nor strong, but could be coincidental. Again, keep in mind that we are talking about variables here. Correlation and regression only relate to the comparison of variables. What if we want to compare groups? A group of variables, for example, or two populations. A correlation does not really help us here. We need to use a different statistical test, and that is ANOVA or ANOVA. The pronunciation is not important, as both are considered valid and they are used interchangeably. The term ANOVA stands for analysis of variance. So exactly what are we measuring? In ANOVA we are measuring or compare the two means of the groups or populations we're examining, and the term 2 is actually incorrect. One of the main assumptions of ANOVA is that we have to have 3 or more groups in order to perform the statistical test. ANOVA will tell us if two groups or two populations are similar or dissimilar, but will not tell us why or in what direction. So ANOVA is a very useful test. Imagine that you're a hospital administrator and you want to compare the productivity of your 3 shifts A correlation analysis will not be good enough because it can only tell you if there is a comparative similarity or dissimilarity between two employees. But if you want to look at a group of employees, ANOVA is your test. I hope this is useful. Feel free to ask questions in the comments area and email me, and I will try to answer your questions. Thank you very much, and I will see you soon in the science broadcasts.